last two keynotes will focus on AI. I'm sure you are waiting and expecting this, and obviously we could not integrate it in the program. So the first keynote speaker's main message probably is that building sovereign AI infrastructures doesn't necessarily have to be complex or costly. Before introducing him, we would like to show you a short video that will tell you a little bit more about this already.
I am a translator, transforming text into creative discovery. Movement into animation, and direction into action. I am a healer, exploring the building blocks that make us unique. Modeling new threats before they happen. And searching for the cures to keep them at bay. I am a visionary, generating new medical miracles. And giving us a new perspective on our sun to keep us safe here on Earth. I am a navigator, discovering a unique moment in a sea of content.
We're announcing the next generation.
And the perfect setting for any story. I am a creator, building 3D experiences from snapshots and adding new levels of reality to our virtual selves. I am a helper, bringing brainstorms to life.
From different angles.
Sharing the wisdom of a million programmers. And turning ideas into virtual worlds.
Build Northern Forest.
I even helped write the script. Breathe life into the words and composed the melody. I am AI, brought to life by NVIDIA, deep learning, and brilliant minds everywhere.
Introducing the Vice President Enterprise Solutions and Operation from NVIDIA EMEA, Carlo Ruiz.
Thank you. I thought let's start with a video, and it makes it look so simple, but it's not. It's so hard. And every year we make this video reel to take some of the most exciting projects we have worked on and showcase them to the world. So my secret mission at events like this is to find the next project for a video. So if you have something exciting, let me know. All right, so my name is Carlo Ruiz, heading up the Enterprise Solutions. I do that for the Europe, Middle East and Africa region. And today I'll give you a different perspective. I wanted to talk about sovereign AI strategies for countries. And it might give you something to think about, how you can approach these opportunities. I'll give you a little bit of an update on the AI landscape and what's happening there. Then we'll talk a little bit about nations' AI strategies. And then we zoom in on a couple of examples of leading nations in the world. Now, one question that I get quite often is, how is it going with AI? How will it develop? Is this a hype Is it a bubble that might burst anytime soon? Might also be investment related, right? When the question comes up. And I think there are two types of people in the room. Those that are experienced with AI, and you have the feeling we just are scratching the surface, right? So the very first projects are deploying right now, and there's so much more to follow. If you look at the potential of foundational models, we have seen the more data you throw at it, the more compute you add to it, the higher the accuracy of the models is. So there's no end in sight for the next few years there. On the other side, when it comes to serving out these models, that's also just starting, right? So taking these models, taking Gen AI, and bringing this to practical applications, it's just at the beginning. So this is looking really good. Now, on the enterprise IT side of things, the realization needs to come. And also, in particular, about how do you take these things in production? How do you do that in a smart and safe way? And that's something that we need to work on together. Now, sovereign AI, that's a big topic. And if you look at my region, we have many countries, and several of them, not all of them, they have strategies in place to address this. And earlier this year, we had Jensen Huang, our CEO and founder. We had him on the central stage at the World Government Summit. And our key message that we shared there is that as a government, you should not be mystified by what AI can do. AI doesn't need to be overly complex. It doesn't need to be costly. It isn't complex to get started. But it's key that you understand the potential here, right? So you don't want to be sending your data, your IP, somewhere else. You need to have your own investments. It can be vital for national security. It can be vital to also represent your cultural identity and keep that and make that available also for the ecosystem that you have in your country. And what's happening? Well, there are quite a number of initiatives. If you look at the news every day, you will see many announcements. And maybe some of them will actually do something. I think there's also a little bit of a delta between those that talk about it and those that really action it. And you might find that also visible in Europe. Some countries are absolutely leading, and some are a little bit behind, to be fair. That raises the question, what do you need to come with an effective national AI strategy? And this is what we normally recognize. You need to create this AI nations stack, a couple of things that you need to tackle. We looked at the 193 countries around the world, and only 70 have a complete strategy in place right now. And the most important thing is that you start with this policy, this national AI policy, that you have that in place. And it's then also about recognizing the fact that this is not about AI, this is not about technology, this is really about the economic future of a country. Much of the disruption, much of the innovation is happening now. So either you're at the forefront or you will be a little bit behind. So the realization on this top part of the model, that's the crucial part. Then you bring the other parts of the stack in place. Of course, you need to have an AI ecosystem, a local ecosystem that includes investors, that includes startups, that includes scientists that are working on AI, but also AI to be applied to the core science that is already existing in a country. Another part is, what are you going to do with your workforce? Those that need to make the move, that need to become AI savvy. So there we talk about upskilling programs and reskilling programs. Very important to have these in place. And do we have our own AI models? Do we have these large language models that represent the local language and the local culture? Some have, right? We have great collaboration, for example, in Spain on the Catalan LLM, right? That's well represented, but I can mention many other languages that don't have their own LLM. So quite vital to think a little bit about that. And then, of course, you need to have AI factories. And I will zoom in a little bit on that later on, but you need to have the technical capabilities to do all of this work. From our point of view, it requires a full stack approach. This is not about a chip, this is not about a GPU. And sure, you need to have an underlying infrastructure. And we're very active on the infrastructure side. we have networking, we have CPUs, we have GPUs, all of that is in place. The important part comes above, and this is where we set ourselves apart from other technology players in the market. You need to have the software that works in tandem with the underlying infrastructure. And there are things there that you need for development. There are things that you need for production. For example, you see there the NIM microservices. Those are the modules that are going to help you with the inference to scale out once you need to serve out these models in a safe way. Then it's also having access to all kinds of models in a standardized way, whether it's community models, the models that we have made. So how do you access that? And then we have developed all these domain-specific SDKs to help people with the development. And that could be for smart cities, that could be for healthcare, that could be for those that want to develop robots, self-driving cars, life sciences. So all these work streams are available for nations, for developers to tap into. And then on top of that, we agree on certain specific collaboration. One side that could be on national AI initiatives, where there is research and development in a certain specific direction. It can be about that AI workforce. So in some of the countries in our region, we have deployed AI academies with the government. Or in large enterprises, we deliver courses to help people apply all of this technology for their specific domain. That's something we call the Deep Learning Institute. Lastly, you want to develop that AI ecosystem. So in a country, you have maybe the need to accelerate the startup scene. And for that, we created something called the NVIDIA Inception Program. In every country, we have hundreds to thousands of startups, which we want to bring to that national platform. Now, let's talk a little bit about the sovereign AI factories. Now, we said sovereign a lot today, but it's about the capabilities to have your own destiny when it comes to having the resources to get this work done. And the resources, they do take quite a bit. And you need to think about establishing that platform. It's large scale, larger than some of the things that we have ever seen before. It's even not all about the compute. I will actually say that networking is more important than the compute when you establish these factories. And the other thing, it's not just a data center. A data center is something that costs money, right? But once you establish an AI factory, where you have the infrastructure, where you have all the tooling, where you have the collaboration in place, then you will be in a situation where you have raw data coming in and intelligence value coming out. So quite crucial to take control of that and make sure that's available in the nation. Let's talk a little bit about the size required. So on the left-hand side here of this graph, you see some of the cutting-edge research that's being done on foundational models. And if you look at the required computational resources, that keeps growing, and you see that the graph is going steeper. The moment that the graph is going steeper, there was the introduction of transformer models, and that enabled the large language models that we see today. The scale that we're using in that graph is exponential. So it's an exponential growth in computational requirements. The fascinating thing here is the more data we use, the more compute we add, the better the models are getting. And there's no end in sight, so this will continue. So if you want to be a player in this part of the AI race, then you need to bring resources in place to get that done. On the right-hand side, you see one of our efforts to work on standardizing these AI factories. So we have created reference architectures, whether this is going to be consumed in the cloud, whether it's going to be on-prem. There is a reference architecture that will help with establishing these AI factories. And it can be a small cluster, but quite often we see that the unit of compute is no longer a couple of nodes. It's about full data centers. That's the unit of compute that we're talking about. This doesn't need to be complex. Following the blueprint, we can roll out these extremely large AI factories in a very, very fast and simple way. And especially since all the software and all the implementation is part of the projects, this can go fast in a simple and a cost-effective way. Now, one of the questions that comes up quite often is, what about the energy efficiency? What about the cost of all of this? The fascinating thing about accelerated computing is that it's very efficient. It's extremely efficient. That's also the reason why it enables AI, right? It wasn't possible before. For the first time, we get the performance and it becomes affordable, and we have it in a format that it can actually be done. And here is an example where we take a workload, in this case is an AI workload, and if we would apply conventional computing to it, we would use around 1,000 server nodes with a dual CPU setup. The same workload can be done on 2 GPU servers. Of course, in combination with the right software layer, right, to make sure the acceleration is there. And then it will happen at a fraction of the cost, with a fraction of the energy. This will lead to 2 things, right? There's 2 directions you can take from here. You can work on these larger models. For the first time, it becomes possible to go a step further. And we see quite a number of those projects in the world. But also, suddenly we can enable a startup that couldn't have all this computational power available to them. Suddenly it becomes affordable, and they can start to work on a breakthrough that they had in mind. So very exciting, very efficient, and one of the most sustainable ways to do computing. Now, if you're looking for facts on the sustainability, have a look at the Green 500. That's the listing of the most energy-efficient supercomputers in the world. You will find that the top 25 is dominated by NVIDIA-powered supercomputers. But more interesting is the top 3. All European supercomputers based on this reference architecture for AI factories. Okay, so we talked about AI factories. We talked about what it takes to be an AI nation. Now let's look at a couple of examples of where we have applied exactly this. In Japan and Taiwan, we have very close collaboration with the government. And one of the things that we saw is that not for every project you want to create your own foundational model. It requires large investments. You need to bring these large AI factories in place. In some cases, maybe you want to take an existing model, adopt that, add your local domain-specific knowledge to it, customize it, and then deploy it. But you want to do this in-house, right? In your country, not somewhere else. And that's the differentiator here. So we have created these tools, made them available. We've created a blueprint for people to take exactly this concept and then deploy it, whether it's on-prem, whether it's in the local sovereign cloud. All is possible, and you can switch whenever you want. The other thing that we have added are the tools to take whatever you created and then deploy it at scale. That's the important part that's often also missing. And then again, in a way that you can do all of this under your own control. And that's the part that we call the NIMs, the NVIDIA Inference Microservices. Now, this is deployed now in Japan and Taiwan, and we're rolling this out over the world, giving people the recipe to replicate this. I spoke earlier a little bit about some countries leading and some being a little bit behind. And we have a fantastic best practice in Europe with Sweden. Sweden was one of the first to recognize the importance of having a sovereign AI platform in place. And quite often success is determined by having a visionary leader. And in this case, Marcus Wallenberg was the catalyst to get things done in Sweden. He saw quite early that it's important for industry, the public sector, and the complete academic environment to work together. There was quite a bit of investment that went into there. But one of the key essential tools to make it happen was the Basilius platform, a large AI factory which enabled Sweden to work, for example, quite early already on a Swedish foundational large language model. Great example of how you can do this. And today they are in the 3rd iteration of this platform, and they're keeping up with all the latest technology introductions. Maybe a little bit closer to home for some of you, right? So here we have an example with our great partner Scaleway, part of the Iliad group. Also there was the recognition by the leadership that AI was disrupting the whole industry and that some players were doing massive investments and moving very fast. And the question comes, what are we doing? What is our nation doing? Where are we going? So the organization decided not to wait, but to also do a large, at the time it felt like a very large investment, but the reality is that it's quite affordable to do things like this, but you need to make this step forward. So they made the jump, they hired the talent, very important, not just to offer the platform, but the talent that understands the science behind it, that looked at the potential, how can we implement and use the technology ourselves. And then the extra step that they made, which was really interesting, was that they said, we're going to develop the French AI startup ecosystem. And they did that very successful, because there's a large group created in that ecosystem. And it's not only the small guys, but also the extremely large unicorns that develop very quickly are on this platform, on this AI factory. And also for us in a collaboration, what's the interesting part is they understand the whole value prop, right? It's not about a GPU, it's not about a data center, it's about this whole factory, including this software stack that I mentioned before, the Taiwan and Japan example. So if we bring our startups, and we have this whole startup community available, if we bring them to the scale we set up, they will land on this complete AI factory and they can use all the software that's available from NVIDIA side. So very good collaboration that we have there and very successful in France. Last example that I want to give, and I want to go a little bit more in depth, that's something that came out of India, it's quite recent. Maybe a question before I try to explain it. Who of you knows what a RAG is? A retrieval augmented, yeah, okay. A couple of you. So to explain it and simplify it a little bit is you can have an AI that can look up search results for you. Instead of presenting you with the search results, right, it will take other knowledge that it has to present the results in a certain format to you, right? So think about, if you don't know about Perplexity, look it up later. You will love it. You won't search it in any other way again. So instead of giving you search results, you will get the answer to your question. Because the RAG, together with the large language model, is going to produce the answer for you. So not just the results. Now, in India, they thought, what can we do with this new RAG approach? And they looked at cases where they could apply this to applications in the public sector. And one of the domains where they had a lot of pressure is in the judicial system. And when the team was explaining this to me, I had to go back to them and say, is this really true, the workloads that you're talking about? Every day, they have 50,000 court cases in the higher courts and over 1 million in the district courts. Can you imagine the administrative burden that they have? So they came up with this concept, how can we use this RAG approach? From the toolkit that we have at NVIDIA, they took a couple of elements. So automatic transcription, that's one part. The other part was about translation. In India, you have many languages. So how can we automate that in a workflow? So they inserted that into the system. Conversational AI, how can you talk? How can you also come back with voice, understand the recordings that we have there? And then they took also this whole RAG pipeline that we have in place. So the results are that you can take this workload, you can archive better, but you also make it much easier to go into the content, raise questions, find examples, query it later. And I think this is a great example where you see a nation leading in a specific domain. Now, I'm from the Netherlands. We don't have something like this for our judicial system, so I find that fascinating. So one of the missions that we have is to take these best practices and share them with other governments, take the blueprint and make them available for them. All right, these were some examples. I think that brings me kind of to the end of what I wanted to share with you. I think you have this high-level approach where we see we're just scratching the surface of what is possible with generative AI. Some governments are very active in setting their national strategy, but not everyone is. So I think if you're a local player, you have a role there as well. You can lead. And very important is think about this concept of AI factories, right? By the end of the day, it's a technology game. You need to have the underlying platform in place. All right? Let me leave it there and see if I can help you with any questions.
Thank you very much, Carlo, for introducing us to this fascinating world indeed. Do we have questions from the audience? Yes, over there.
Yeah, Laurent Blin from OVH Cloud. One question regarding quantum usage. Do you see a lot of requests from government having quantum that you are also addressing with some specific cards?
Yeah, absolutely. Quantum computing is an interesting field for us. Here comes the fascinating part. We see that the practical use of quantum is a little bit out. It's at least commercial use, a couple of years out, at least. But how are you going to simulate that today? How are you going to do the real work? So we see that these AI factories are being brought to use to simulate what you could do in the future with quantum computing. And also there we decided to create these libraries. So we have something called QQuant to help researchers to model already for the future of quantum computing. So practical application a little bit further out, but for us an important field because we can help with the simulation and see how these systems will act in the future.
Thank you.
Another question, one of the last ones of the day. Yes, madam.
Hi, I'm Charlotte from Oracle. So I have a question. We work with you guys, as many of the others, I guess, in the room. Thank you. Hi, I'm Charlotte Toomey from Oracle, and I have a question about sustainability. You mentioned it a bit here, and as many other in the rooms, we already work with you. You mentioned that the energy efficiency is going to be much more sustainable in the use of the setup of the AI platform. But we also understand that there's going to be such a huge amount, there's going to be a need for such a huge amount of GPUs used in the in the more complicated AI models, so that yes, there's a very, very good CO2 footprint story, but there's also going to be enormous requirements for an increased usage of energy. Sorry, I have a cold and it's a little bit, yeah.
I get the same now.
Sorry. So the question is, how do you plan for that in terms of, because in terms of your data center rollout and you know, for example, in Europe, the whole CO2 footprint is a very big debate. What is your plan there in terms of trying to calm the markets? Because as we know, we have an issue with energy import from countries around us that maybe not so friendly minded, and we are trying to replace it with solar energy, etc. But what is your what is the vision there to ensure that we will not, have an issue, a huge issue in terms of energy usage for AI that will take away energy from other important infrastructure resources in the future?
Yeah, I think that's a fascinating question and leads also to some other interesting topics. So first of all, without a doubt, it's the most sustainable form of computing that you have, right? But if you start using more, it offsets that thing, right? It's a fair comment. So you need to think a little bit about that. There's one thing that you should notice as well. This is not like conventional computing. We have massive generational leaps. If you look at every step that we make with a new generation, this energy efficiency jumps up like nothing you have ever seen before. If you're interested in this topic, look a little bit at sustainable computing. We do quite a bit of publication about this. That doesn't mean that we don't need to address the other parts, right? But that's number one, which makes it very interesting. The other thing is, all of this is about AI. What if we apply accelerated computing to all those conventional workloads that are not accelerated? There's so much that is not accelerated. If we would take that and put this on this platform, that would be a massive contribution to sustainable computing. That's another step. Then we are applying also AI to sustainability. For example, look at our Earth project, where we're making a digital twin of the Earth. So if you really want to understand climate science, you need to do compute at a scale that was never possible before. So there are things that we're working on there as well. However, with this audience, I'm going to make an additional remark. You also need to be ready for this new type of computing. And many are not ready. Right? So we can work on density. We can work on increasing the flops per watt and so on. But that means also that we're looking for density. And so in the new generations of equipment that we're introducing, suddenly we're looking at 132 kilowatts per rack. And there's a role here to be ready for that. And when it comes to the nation's capabilities of doing something, if you don't have the data centers, you'll not be able to do any of this. And that's fascinating as well. And I think from a sovereign AI point of view, I think there's also a role for some of the players here to be ready for this. Does this give you an idea? It's a very wide topic, but I try to address it a little bit. Yeah.
Great. Many, many thanks, Carlo, for answering those questions.